Okay, guys. Hi, I'm Adam. I'm the co-founder and VP R&D of Applitools. We're a company that provides a cloud service for automated visual testing. Very happy to be with you here today. And today I'll talk not about Applitools, but on automated visual testing in general. So, um, as part of my job, I get to meet a lot of developers and testers, and I'm always curious to learn how they do visual testing. And the two common answers that they get is one, that they have no idea what visual testing is, and the second one is that they think I'm asking them whether or not fully, and tell that to everyone you know. That would be a little bit. Okay, so we have quite a lot to cover. We'll start by explaining what visual testing is and why it should be automated. Then we'll look at the different tools that are available out there and the technology that they're based on and how they work. And we'll conclude the session by describing how visual testing fits in your modern deployment lifecycle. And we'll have time for questions and answers, but in this forum, feel free to stop me at any time if you have any question or anything. Okay, so what is visual testing? It's a quality assurance activity that is aimed to verify that the graphical user interface appears correctly to the end user. This goes beyond the traditional functional testing that you used to do with tools like Selenium or Appium, likewise, where you actually test the functionality of the product through the UI. What we're focusing on here is making sure that the UI itself appears correctly to the end user. We want to make sure that each UI element appears in the right color, shape, position, and size, and that it doesn't overlap or hide any other UI element. And of course, this type of testing has become increasingly difficult to perform in recent years, mainly because of the explosion in the number of devices, operating systems, browsers, and screen resolutions that applications are expected to run. So here you can see an example of a visual bug that we found in the, okay, this doesn't work, that we found in the Microsoft Azure Management Portal. You can see here how the graph here exceeded the expected bounds of the page. This is an example from Twitter. You can see how in their app for some time the timestamp of the notification overflowed on top of the notification below it. This one is from the Financial Times. Here the article title overflowed on top of the article body. And this is how the Amazon website looked like for several hours on Amazon Prime Day a few months ago. So I'm sure you've all seen these issues before, hopefully not at work, but definitely at home. I'm sure you are aware of their severity. They can be very embarrassing, they can be hurtful to the company brand, but in many situations they can completely cripple the functionality of an application or a website and end up costing a lot of money. That's probably happened in this case. So why should we automate visual testing? There are many reasons, but the most important one is that the test matrix is just too big to cover manually. Think of all the different web browsers, devices, operating system, and screen resolutions that your application is expected to run on. We all know that if a website looks good on IE, doesn't mean that it would look good on Chrome, right? And if an application looks good on a widescreen, doesn't mean that it would look good on a smartphone, right? So we have to test on all these different environments, execution environments where application is expected to be used by our users. If the application is responsive, and most modern applications are, then we need to test all the different layout modes in all these different execution environments. If it is localized, then for each language we need to factor in the different fonts and images and texts, right, and resources that are specific to a language. And even if we don't touch our code, we don't change a line of code, there are still those third-party upgrades that can mess up things for us. So just a common example is the web browser, right? It upgrades every couple of weeks. We have nothing to do about it. There's nothing we can do about it. But still, whenever it upgrades, it can introduce incompatibilities into our website or web application, and when that happens, there could be bugs there. So we have to constantly test and test and test. It's very difficult to do right and effectively manually. When it comes to mobile apps, quality is even more critical, and one of the main reasons for that is the fact that we can't roll back changes. With a web application, if we see that we have a bug, we just update the website and there you go, it's gone. With a mobile app, you can't push daily to the App Store, and even if you find a way to work around that, the frequent updates will take battery and data and eventually upset your customers. So you cannot rely on that as a solution. And in general, there's a much higher quality bar when it comes to mobile applications, just because mobile users are much less tolerant to UI and UX bugs. And of course, release cycles keep getting shorter and shorter, and this is the business pressure that we all experience. Companies that are doing continuous deployment today, which is the recent hype, release code to production several times a day, and with such short release cycles, it's quite impossible to do any type of manual testing, let alone making sure that your application looks right on so many execution environments. So now that we understand what's the motivation for automating this type of tests, let's take a look at the tools that allow us to do it. If you have any questions, feel free to ask, right? Just so how do these tools work? So there are many, many tools, and all of them share the same workflow. Very simple workflow that have 4 steps. In the first step, you drive the application under test and you get screenshots. You can do it in many, many ways using various test automation frameworks, but at the end result you have screenshots that you want to verify. In the second step, the tool takes those screenshots and compares them with baseline images. These baseline images define the expected appearance of the application. Okay? In most cases, these are just screenshots that were previously taken by the application, that they sent by the tool, but were approved by a human tester because they are valid. Okay? In the third step, the tool generates a report that includes all the screenshots that were taken, the baseline images, and any differences that were found. And in the fourth step, a human tester has to look at the report, assuming there were differences. Okay? If there were differences, he has to decide for each difference if it's a bug, in which case he opens the bug. But if it's a valid change to the application, then he needs to approve the new screenshots to be used as baseline for subsequent ones. And of course, there's a special case where the first time you run a test, you still don't have a baseline. So the first run sets the baseline, and from that point onwards, you always have a baseline to compare against. Okay? So now that we know how this tool works, let's look at our first demo. And this is a demo of an open source visual test automation tool that is called WebDriver CSS. And it is a JavaScript-based tool that extends the WebDriver.io WebDriver language binding. Okay? It's a popular language binding in JavaScript. So for those of you who are not familiar with WebDriver.io, let's look at the trivial test with WebDriver.io. It still has nothing to do with visual testing. So as you can see, it's JavaScript based. So it will be a bit difficult for me to highlight stuff here by holding the mic, but I'll do my best. We start by creating an instance of the driver, okay, and we tell it that we want to run a local Chrome browser, okay. This is the initialization part. We start the test by initializing the driver, which causes the browser to open. Okay, then we navigate to WordPress.com, and then we just wait for 10 seconds, and then we close the browser. Okay, that's what this test says, and it's quite obvious and clear. Let's run it and see what happens. Okay, as you can see, a local Chrome browser just started, and we have the WordPress.com web page loaded, waiting 10 seconds, and it will close. Very simple. Now we are going to add WebDriver CSS to provide us with visual coverage, okay? And the way that we do it is that first we create an instance of WebDriver CSS and we initialize it. We provide it with the driver that it will extend with visual coverage abilities. and we specify 2 screen widths that we are interested to test. This is useful in cases where our application is responsive, because what WebDriver CSS will do is that it will resize the browser to these widths and will force the application to assume the layout that you want to test it in. So here we specify 2 widths, you can specify as many as you want. And within the test itself, after we navigate to WordPress.com, we specify a visual validation point. In the case of WebDriver CSS, it's called WebDriver CSS. And what you provide is a name for the checkpoint. In this case, it's WordPress. And then a list of elements within the current page that you want to check. Okay, so in this case, it's just one element, which is the body element, which means that we're going to validate the entire page at once. Okay, but it doesn't have to be the entire page. And you specify each element with 2 arguments. The first one is a CSS selector that specifies the DOM element that you want to verify. And the other is a name, a symbolic name that would appear in the report for that specific element. Okay? Let's run this test and see what we get. So the browser just opened in the background. I won't touch it, so I won't interfere with it. You can see the first resize, so it's quite narrow. Then the second resize, and we're done. Done. If we look at the folder where I just ran the test, you can see this is the first time I ran the test. So we just created baseline images, right? And this is how it looks like with WebDriver CSS. You can see that I have here 2 images. Let me close it for a second. You can see the WordPress checkpoint. You can see the body element. These are the 2 names that we provided, right? You can see that there are 2 of them because one of them is with the 360 width and the other one is with the 700 width, right? It makes sense. And if we look at the image, you can see that actually we got a full page screenshot. Although Chrome, if you're working with Selenium, you know that it only provides you just what the viewport shows, right? Unlike Firefox that allows you to get the entire screenshot. So what WebDriver CSS actually did is that it actually took several screenshots. It scrolled and took those screenshots and stitched them for you and got you a simulated full page screenshot, okay? And you can also see that WordPress.com is actually a responsive website. You can see how the layouts are completely different, right, between those 2 screen widths, okay? So our next step is actually to simulate the difference and see how WebDriver CSS can capture that for us, okay? So the only difference in this version of our test is that I'm injecting I'm running some JavaScript on that page, and I'm locating the create website button, and I'm hiding it. Okay, so that would be the change that we expect to see on the page. Okay, so everything else is exactly the same. I'll just run it now. Okay, the first resize, and the second one. The button is missing there. I'll move this guy here. You can see that the button is missing, as expected. Hello. You found it, huh? This is how they make sure only strong QA guys get this. So I ran the test and we know that there is a change, and this is how WebDriver CSS communicates this change for us. So you can see we have 2 new images with a regression suffix, and this happens because there's a difference. Okay, and if we look at the regression image, you can see actually that we have the missing image here, right? You can see that the button is missing, but we also have a diff folder, and this diff folder shows us the new image, but with all the different pixels highlighted in pink. Okay, so you cannot miss the fact that there's a change there. So this is how, what I want you to realize in this example is how easy it is to take an existing Selenium test, WebDriver test, and with a few lines of code, turn it into a visual test and start capturing this visual differences that you couldn't get with just web browser, right? You had to have someone looking at those pages and looking at the application and seeing this stuff. Okay, so now that we've seen a tool, a visual test automation tool, I'm sure that you are filled with doubts about how stable this image comparison stuff is, and are these tests flaky or not, right? So because of that, I'm going to jump and zoom in on this part, the compare screenshot with baseline images, which is really the most challenging thing that each visual test automation tool should solve, and talk about some of the challenges there and the solutions that are available. Okay. So, if you allow me to quote Boromir, one does not simply do bitmap comparison. And by bitmap comparison, I mean pixel-to-pixel comparison. And the reason is that if you do that, if you try to create a simple a loop that goes pixel by pixel and compares them, you'll get false positives, and you will hate the tool and just throw it away eventually. And there are many reasons for these false positives to happen if you just use like simple, dumb pixel-to-pixel comparison. And let's look at a few. The first major reason for that is an image processing effect called anti-aliasing. You probably heard about it. And here's an example of anti-aliasing. You can see here at the bottom we have a navigation bar, and we have the playlist tab, and it's being magnified here. You can see it up close in the middle of the screen. So you can see at the bottom that the playlist text is written is white, right? But it probably in the DOM it also specified to be white. That's what you asked it to be. But if you look at the magnification, you can actually see that it's not all white. There are many pixels with blue shades there, right? This is anti-aliasing in action. What happens is that the graphics card or the rendering engine that is actually drawing these pixels for you is trying to make the text look more beautiful. It tries to make it appear more smooth, especially the diagonal and curved lines. And it does that by adding pixels of different shades and colors that would create the optic illusion for us that it's smoother. Okay, it's a fantastic thing. The problem with anti-aliasing when it comes to visual testing is that if you're running your test on more than one machine, which makes sense if you have more than one tester in your team, or if you're trying to scale up your test and you run in a lab and you have several machines to parallelize tests, then it's more than likely that you have two different machines there, or perhaps they'll be connected to different monitors, or they have different version of the graphics card, or some settings or configurations that are different between them. And what you get is a graphics card that has a different implementation of anti-aliasing algorithm. Okay? And here's an example how exactly the same application gets rendered on a different machine. You can see that these pixels, the anti-aliasing pixels, are quite different. And actually, it's not easy to see on this screen, but actually, these pixels here are pink, they are not blue at all. Okay? So, but still, if you look at the original playlist text, it still looks the same to us, to the human eye, right? If we don't zoom in. So, this is, if you use just pixel-to-pixel comparison, of course your test will fail because the pixels are different. But you need a sophisticated image comparison algorithm or engine to be able to recognize the fact that this is something that a human cannot see, and therefore it can be ignored. Okay? Another common example is pixel brightness differences, and this could happen even if you have the same computer connected to different screens that have different capabilities. So you can see here the text at the bottom with the word D magnified, and this, look how different it can render on different computers. So what's special about this example is that even in the original text you can see the difference. But still, you don't want your test to fail because of that, because as QA persons, we only want to fix bugs that are actually bugs. And no user will ever complain that the text looks funny, right? So you don't want to have failures because of this, and you want to have an image comparison engine that is smart enough to identify and ignore these issues. Yes, please.
Did you get these kind of artifacts with like an X visual
That is
virtual frame also?
I'm not sure that I understand your...
If you're running your test headlessly like in a VM or something,
Yeah.
you might use
Oh, you say if it's something that... Okay, so if you are running on a virtualized environment where every piece of the rendering stack is virtualized and your software has nothing to do with any hardware on the machine, then you have different false positives to deal with, and I'll show you that, but this will likely not happen. Okay, but anyway, I doubt that there is anything that is that virtualized. Eventually, there are hardware resources that are being used. There's no need to implement anti-aliasing in software, right? You have a graphics card that does that, even if you draw to a memory buffer. So I would assume that you would still have that anyway. So here's an example that would fail even in that case, okay? Even if you had an entirely full software stack that is completely deterministic. In this case, we have a piece of text that's moving, okay? Is there anyone here that doesn't recognize the fragment where this was taken? This is the Dropbox website, right? And you can see that the upgrade account element is moving. The reason that it's moving is because to the right of it, over here, there's a username. And whenever you run the test, there's a different username, and therefore everything shifts and moves to left and right because it's aligned to the username, okay? So we would still want to visually validate that this element looks right, and how do we do it? A very good way to do it would be to just focus and take a screenshot of the upgrade account element or the container, and just compare it with the screenshot of the container, and then it doesn't matter where it appears on the page, we can still validate that it looks right. The problem is that, again, with simple pixel-to-pixel comparison, it won't work. And the reason is that although the upgrade account is moving, it seems like it's moving as a whole, actually each individual element, each individual letter is being positioned separately by the browser. And if you look at the A and C and U letters on this page, you can see how that they actually position at different pixels. And then again, with pixel-to-pixel comparison, these would fail your test. Okay? Or force you to set some kind of high threshold that eventually allow other bugs to appear. Right? So then again, you need a smart image processing algorithm that will be able to see that this is what happened, that a human being doesn't see that, and it can be safely ignored. The last one in this series of examples is a very, very common one. It has to do with image scaling. Whenever you have an image placed in your application or website, and the bytes that it reads and populates that image are of an image that doesn't have exactly the same size, what happens is the rendering engine has to scale that image, that original image, into that target bounds, right? And then again, two different rendering engines, two different implementation of a scaling algorithm. And as you can see here, we have this pink rectangle here at the roof of the car, and this is how it looks like. And this is how it renders on a different machine. You can see how different the pixels are. Almost all of them are different, but still it's completely invisible to us as humans, right? But if you use pixel-to-pixel comparison, it will fail. And if you think the problem is difficult to solve, then this is just the beginning. I mean, there are still 1 pixel offsets in element positioning. It could be just a line of text that moves to the 1 pixel to the side, because that's how the layout engine of the browser made the decision that it needs to be a bit 1 pixel to the side, even on the same computer and the same browser. And it could also be that your web page is built with an HTML table, and for the same exact reason, one of the columns got to be 1 pixel wider, and that moved the entire page 1 pixel to the right. And you have an 80% pixel-wise change on the page, but still for a human being, it looks exactly the same. Right, so you need to be able to handle that. And you need to handle dynamic content like dates and ads and all of that stuff. And there's moving elements like animation and all the update account that we saw that is moving. And you need to be able to handle comparing images of different sizes. And of course you need an algorithm that runs really fast, otherwise your test will take forever to run. And of course there are those that always get mismatches and false positives, and they are hopeless. But to be serious, all these visual test automation tools have come a long way in recent years to handle the majority of these issues, if not all of them. And if you want to use a visual test automation tool on your product, make sure when you test it that it is extremely stable on your application, because if you still get those false positives, you will never be able to scale up your tests. The more tests you will write, you'll get more false positives that you have to look at, and they will just annoy you, and eventually you'll give up. Okay? So, what are the image comparison engines that are available? It's not like every tool invented its own engine. There are a few common ones that are used by all of them. So, the oldest and the most, one of the most popular ones is a command line tool that is called ImageMagick. ImageMagick is a general purpose image processing tool that can be operated with from the command line, and it can do a lot of stuff like take an image and convert it to a different format and change it to black and white, and do all kind of image processing filtering on it, rotate it, all that stuff. It also has a single command that can compare two images, okay? And this is how it looks like. You provide a first image, a second image, and what it outputs is that it gives you a diff image as an output, which is basically the second image with all the different pixels highlighted in pink, exactly as we saw with WebDriver CSS, okay? And it also outputs the number of pixels that are different. Okay? It has a nice fuzzing feature that generally does some kind of summing of the different pixels at each location around each point, and it is able to therefore overcome some of the anti-aliasing and scaling issues that we've seen before. And the tools that are based on it always provide you as a user the ability to specify an error as threshold that determines if the images are matching or not. This is probably something that you're familiar with because many tools rely on that. So they actually, if you take this number that of different pixels and you divide it by the size of the image, you get an error ratio. And then the tool exposes this to you and tells you, so let me know, what is the threshold of error that you consider the images to be different, okay? So you can say if it's more than 0.5%, the image is mismatched. If it's less than that, the images are matching, okay? Then there are three JavaScript engines, the most popular of which is Resemble.js, and which is the engine that is used by Phantom CSS, if you're familiar with the tool. It's one of the more mature tools that are out there. They all do pixel by pixel comparison. They all rely on error ratio to work, they let you decide what the error ratio is. But they also do beyond what ImageMagick is doing, it allows you to do, which is a general purpose image processing tool. They do handle all these specific issues that we've seen before. So Resemble.js has very good anti-aliasing support. The others have more or less the same support and some more features like ignoring differences that look like a blinking carrot. So if you have a text box and sometimes you see the carrot, sometimes it's not, they will ignore that. So all kind of features that allow you to have more stable tests. Just to show you something nice about Resemble.js is that the guy who built it did a very nice job in building this website. And you can actually take two images. Let's take the example we had before. And you can actually drag one image and drag the other. And you can see the different diff image here and play with the arguments of the algorithm, and you can. It's very easy for you to just try it on your website without writing code. So it's a very nice tool with very nice comparison. And we have our own Applitools Eyes engine that we've developed from scratch for many years now. And this was actually built to do like commercial, heavy-duty, very large-scale testing with a lot of stability and speed. It handles all the issues that we've seen before. It can handle dynamic and moving content, you can compare images of different sizes. The one thing that is very special about it is that it doesn't require you to provide an error ratio. So if a human being can see the change, it would flag it. If a human being cannot see the change, it won't flag it, and it has nothing to do with the size of the images being compared or the size of the change. So it could detect a comma changing to a period or a plus symbol changing to a minus symbol on a huge web page. But on the other hand, like the example I said, if the entire page moved by 1 pixel to the side because a column became 1 pixel wider, and it could be a huge change, it would still not flag it as a change. It's very fast, and it also supports matching images by their layout or structure. And to explain what that means, I'll show you a demo this time with Applitools. Okay, so layout matching has two main applications. So the first one is doing cross-browser and cross-device visual testing. So in this case, we have a baseline image here on the left that was taken on Chrome, and a current image, which is the image that we're validating, that was taken on IE. Okay? And if I toggle between the two, you can see how the different browsers render the same page differently. The fonts are slightly different, their position is slightly different. As a result, the text here in the paragraph can wrap differently. Okay, but then again, this is fine. I mean, nobody really tries to make his site look exactly the same on all the different browsers, right? But when you do layout matching or structural matching, you can actually make sure that by structure these pages are consistent, and they are. We have this radar button here that if we click, it highlights small differences that we might miss. And you can see that we actually do have a difference here at the bottom of the page. And if we zoom into it, you can see that we actually have a missing element in IE. Okay, and again, this shows you how useful layout matching can be in that case, that it can handle varying renderings by different browsers, devices of the same page, but still identify things that structurally are different. So let's take a look at another example, this time with a mobile application. And this one is with Twitter. And there are a few variations here. So we can see that the first tweet, if you look at the baseline image, it dictates that it should be aligned to the right of this icon, right of this image. And you can see that it's being violated here on the right hand side. And here at the bottom, you can see that the last tweet should have an image, but it's missing over here. So all these issues are correctly detected. But if we look at the two tweets in the middle, although they have different images and different text in their paragraphs, still structurally they are consistent, and so the two won't highlight them as different. The last example shows another application of layout matching, which is validating extremely dynamic web pages or applications in production where you don't really control the content of what's being shown. So in this case, we have the Yahoo website where the baseline image and the current image were taken at 24-hour difference. And you can see how different the images are and also the articles that are being shown. But still, structurally, these pages are consistent, and therefore this specific test is passed. If I would change this to a more strict comparison, then you can see that all the dynamic parts are highlighted, okay, as different, and all the static parts aren't. If I would do pixel by pixel comparison, you can see that effectively everything here is different, only that the strict matching is smart enough to ignore the stuff that we cannot, the differences that we cannot see as humans. Okay, so that's all I have to say about image comparison. If you have any questions at this point, fine. Otherwise, we'll move to other. Yeah.
You said that like if there's like a 1 pixel creep on the sort of table views on a column, it'll sort of ignore it.
Yeah.
But if it creeps, like does that assume that's the new baseline, or does it like so if it creeps 20 times, still doesn't care, or
so the question was how how if it creeps, is it assumed that it's if it's a new baseline or if it's okay? So what I've focused right now has nothing to do with the baseline.
Okay, no.
We're just considering the technology for comparing two images and whether the tool will report it or not.
Okay.
So the main thing is, I think, if I would summarize what I've just said, is that there are two types of tools out there. The entire world that forces you to specify thresholds for mistakes, and Applitools eyes that allows you to not specify that and rely on the tool to let you know if a human can see it or not. So that's the basic thing. It has nothing to do with baseline at this point. And
Thank you.
okay. So let's take a look at the first step and how the different tools handle driving the application on the test and take screenshots. Okay, so all the tools have the same workflow, but you can still categorize the different tools into two categories that have different usage, different intentions, different problems to solve. The first category of tools are the quick feedback tools, and they show the following setup. They render the screenshots with the headless browser. Normally those would be Phantom.js and Slimer.js. Okay, you want me to explain in a sentence what the headless browser is? Yeah? Oh, okay, you know, but okay. And they would also rely on a configuration file to drive the test. Normally just a list of URLs that the tool would visit and check. Okay? The motivation for using this type of tools is basically to get fast feedback on code changes. So these are more often used by front-end developers that work on a new component or change a certain page. They touch the CSS file and they want to get quick feedback and make sure that the changes that they did didn't ruin some other components or pages that they didn't intend to. Okay? And being front-end developers, they want to do as little testing as they can, so they don't want to learn any new language and would rely on a heavy framework, or God forbid that a browser would open and interfere with their work. So they want to run the test locally in the background, and that fits with having a headless browser working in the background and not popping any browsers that interfere with the work. And this is very useful and effective. On the other hand, it has disadvantages, and of course the coverage is extremely partial. If you focus on Phantom.js and Slimer.js, you have no coverage for Chrome and IE, which are rather important web browsers, right? And also, if you rely just on URLs and a configuration file, you have very limited navigation in your application. You cannot fill out forms, you cannot hover on components, you cannot do anything sophisticated. So it's quite superficial. And of course, even by using Phantom.js and Slimer.js, you're using stale browser versions. Browsers update every 2 weeks, 3 weeks, and Slimer.js and Phantom.js update every few months, if you even then bother to update them. So it's quite possible the test would pass with Slimer.js, which uses Gecko, which is the layout engine for Firefox, but still with the real browser there's a bug, and you won't see it, right? So that's a disadvantage of relying on this type of tools. The other category of tools is the visual coverage tools, and the motivation here is to really do the real thing. You want to make sure that the application looks good in all the real execution environments, on real operating systems, on real browsers, and you want to test as many UI states as you can in your application. You want to, because you probably have a lot of tests, you want to run them in parallel, and as a result, you'll get tools that there are many of them, but they all are based mainly on a WebDriver, and they use a grid to work on these different environments and operating systems, and the tests themselves are written in real code, not a configuration file, and they could either be direct WebDriver tests, like we saw with WebDriver CSS, where you have the WebDriver and you have more abilities on top of it to do visual validation, but basically you can do whatever a WebDriver can do, and simulate whatever a human being can do with the application. And there are others that invented their own domain-specific language on top of WebDriver, but basically they allow you the same flexibility. The disadvantages of these tools is that they actually require you to have a test infrastructure in place, and you need to maintain and create WebDriver tests, which you all know takes effort. But on the other hand, the consumers of these type of tools are test professionals. That's their job. They're experienced in doing this. They probably already have a test framework in place, so it's not really a disadvantage for them. So I've already shown you WebDriver CSS, and this example shows WebDriver CSS code, so I won't go into it again. But this is an example of configuration-driven test. This is a tool called VIF, also an open source tool. And the main thing here is you can see that you specify the location of the application that you want, the website that you want to test, and then a list of URL or the list of paths that are being visited by the tool, and for each path they take the screenshot, compare it to the baseline, generate a report, etc., resize the browser as you specify. VIF is a bit more sophisticated in the sense that you can also, it's not limited just to URLs, you can also attach some JavaScript that would run when you visit that page, so you can actually click some buttons or fill out forms and do a little bit more, but it's not as flexible as you could have with real WebDriver code. The third way is to get those screenshots manually. Just as a manual tester, visit a page, click a button, and have it visually validated. Applitools has a Chrome extension for that. And the main motivation here is basically like you would, just the same way you use a spell checker with your text editor, right? Everyone can check for it by himself to see that there are no typos or grammar mistakes, but it's much faster and reliable to have a tool let you know if there's a problem. Here you can see a sample of the various tools that are available. There are over 30 of them that I know. This is just a partial list. And you can see that there are many that are based on code, on scripts to run the test, and many that are based on configuration files. The important things to highlight with regards to this is that the vast majority of tools that are out there are aimed to test web applications. The only two exceptions are Facebook Snapshot Test Case, which can test iOS applications, and Applitools Eyes that can test any mobile application that is that Appium can automate. Okay, whether it's Android or iOS, and the second thing is that for every let's say popular programming language and every common testing framework, there is a visual test automation tool that you can integrate and add visual validation to it. So whatever you're using today, there is a tool that you can use to do visual validation. The last topic on this subject of getting screenshot, etc., is actually getting screenshot. And it seems trivial because it's easy to get a screenshot, right? But actually there are many nuances and different capabilities for the different tools. So the first one is whether some tools only provide you with a screenshot that the browser or the framework allows you to get, and some do more, like scrolling and stitching and getting you the full page screenshot. Some tools only deal with the entire screenshot with the entire page. Some others will allow you to specify regions within those page components within that page that you want to focus on, like we saw with WebDriver CSS. If you have frames or iframes that can have their own scroll bars like within the application, some tools can automatically get the entire contents of those frames for you. So you can look inside and validate the entire content. There are device pixel ratio issues to handle, like if you're running on Mac, you get, with a Retina screen, you get an image that is twice as big. So some tools will, let's say if they try to scroll and stitch, they would break in those cases. Some other won't break, but they will produce an image that is twice as big, and it won't compare with the baseline image that you got from a normal PC or laptop that you're running on. And some tools can handle that and scale the images so you have, it doesn't matter where you run the test, you can still compare. Especially with Appium, which is relatively a young tool, you have issues with rotation of images. They don't come out right all the time, so some of the tools can actually detect that and and fix it for you. Some tools allow you to specify the viewport sizes to test against, like we saw with WebDriver CSS, it allows you to specify the screen width, and that's very helpful when it comes to responsive applications. In terms of page preparation, some tools allow you to actually mask out certain areas of the page before taking a screenshot. This is useful if you're testing on production data and you don't want to have like customer details that are sensitive end up in your test reports. So you can just mask them out, hide them, or somehow darken them. And when it comes to page stabilization, then I'm sure you all know that it's a big problem for any automation framework, like when the elements are there already, when they can be touched and clicked and queried. So visual test automation tools actually have an advantage there because they have a baseline image and they know how the page is supposed to look like. So some of them can actually wait for that page to get to this required state. So they would continuously, each validation point actually continuously take screenshots until there is a match or a certain timeout expires. So you have much more stability in your test. Any questions about getting screenshots and driving the application? So, yeah.
What did you go for?
One question around scripts versus hashtag.
Okay.
And the Yahoo example,
Mm-hmm.
let's say you have a screen where you have a header there, and you have a given section with data in it, and you're trying to do a non-strict comparison, but you are worried about the headers to be exactly matching. The table and the content inside is random. So how good is the non-strict comparison? Like, will you make sure that the headers are, even though there's a text change to capture, versus the data inside the table is definitely can be excluded and still make a good comparison? How does it work?
Yeah. So I just repeat it so for the recording it will people know what you're asking. So the question is, it's not related to this section, but an image comparison. So the question was, if I have one page, a single page, where parts of it I want to check strictly and part of it are dynamic. So the easy answer is you can test just part of it in a strict way and the other part in a dynamic way. It's fine. You can just focus on the regions that you want and ignore the ones that you don't. You can, for one page, you can specify areas that will be strict and areas that will be. You have to define it. Yeah, or from the SDK itself, you can, from where you run the test, when you do the validation command, there you can even specify the match level. Okay.
Well, that example was
yeah. Yes. But you can also have like different tests, even one that only tests layout, others that focus on. So you have a lot of flexibility in that sense. Yes.
So say you have a button, and then when you hover, the color changes. So that the assertion is true. You want that to make sure that it changes. Would this a tool be for that, or?
Yeah, sure. I mean, you just take a validation point after the hover, and you see the state that it hovers, and you're good to go. Yeah.
That reminds me of a question I had. I was looking at the Sauce Labs page, the home page, and it has a sort of a changing flow. It cycles through some images and moves things around. How would we handle that?
So the easy answer, so there are many ways to handle that. I think it's easiest when your application or website is testable. Right? So like anything else with test automation. So one thing you can do is, if you have good interaction with the dev team, is allow you to freeze the state, right? In the URL, just do some backdoor that freezes it on the first one, and that will work. That's the best solution. If you cannot have it that way, then there are other solutions you can do. First of all, I mentioned stabilization, right? So you can have a very long timeout, and then you just, the tool will sample until it will get to a match, which is the specific state that you want to have. So it's not optimal because you have to wait longer in some situations. The test could be faster if it would be at the state from the beginning, right? The other way to do it is just to write your test in a way that it has
the different baselines for each of the states, and just before doing the validation point, you actually look at the HTML, see what state it is right now, and then you decide which baseline you're comparing against and doing the testing. So there are various ways to do it. And like in any type of testing, if your application is testable, that would be the best way to do it. That you don't need to work around issues. Okay, so the third step has to do with the reporting. Okay, so let's see what different tools allow us to do that. Many tools, the majority of them, just give you image files on the file system, like we saw with WebDriver CSS. I ran the test, I got images on the file system. You have the baseline, which is before in this case, and the current image, which is the after in this case, and the diff image, which shows you the differences. It seems trivial, but it's actually a very effective way to do it, especially for front-end developers if you look at the tools that are for quick data. It's nice because it's lightweight. It's files on the file system. It's easy to take those files and send them to someone to look at, to give you feedback. If you can do it together with a code review, so you have the code changes as well as the differences of the images, and you can commit the baseline together with the code. If you have branches, that you have your source code in branches, you can just keep the images for each branch along with the code that produces them. So it's a simple and effective solution. There are some other tools like Selenium Visual Diff in this case that provide you with a nicer UI that shows you like a summary of all the tests that ran, how many failures, how many successes. You can drill down into the different images and see the thumbprints with the differences highlighted, and you can drill further down and see the differences of rows, etc. And this brings us to updating the baseline. So when it comes to the tools that have files on the file system, then usually they have some kind of command line flags that you run, and they just take those files and rename them so they would indicate a baseline file rather than a regression file. Or you can do it yourself, or you commit the baseline images, and this is how you handle it. And there are others, like in this case, we have Gemini, which is a very nice visual transformation tool that actually provided with a nice UI. It shows you all the validation points, and the red ones have differences. And you can see for each one, the reference image, which is the baseline image, and the current image, and the diff image. And if you want to update the baseline, if it's not a bug, you just click a button, and that replaces the file. And or set something in the database in the backend, and you're good to go. Now, one of the things that is that happens with visual testing is that in some situation, it doesn't happen all the time, but it sometimes happens, that you have a very small change in your application, or one bug, a few bugs, that manifest in many tests. Okay, just trivial example is if we just change the footer of a website, and all those tests that take screenshots of the website of the footer would break, right? If one change would break all your tests. And so it could be annoying, although it would still be much easier to look at those images and approve them. It would still be annoying to look at the same change 1,000 times and approve it. Right? It's not as bad as going through the entire application, but it is still an annoying task. And what you would really want to do is be able to look at each change just once and decide what to do with it. Not look at it like 1,000 times again and again. And this is something that is called automated maintenance and is unique to Applitools, and I'm going to show you this capability. So what you see here is the result of running a batch of tests that have differences in them. So in this case, we have a batch that had 28 tests in it. Can you see it all? 28 tests, they all failed. It covered 3 different environments that are basically 3 different browsers, Firefox, IE, and Internet Explorer. It covered 3 different form factors This specifically is the Google Test Automation Conference website, and it's responsive, so it has 3 modes, and they're all covered. And all in all, you had 91 differences, and here they are. And we can try and figure out what just happened. We can click the radar and see that it's something in the footer, and here, again, it's something in the footer. We can drill down and zoom into it. And we can see actually that the Google Plus product just changed to Google Minus. And let's assume that it's not a bug, it's a rebranding of the product. And therefore, we don't want to open bugs for it. We want to approve those images to be the baseline for the future test runs, right? So one of the things that we attempted to do is just, okay, let's just accept it because, of course, I changed the product name. It appears everywhere, right? But I'm not going to do it. I'm going to click this button here that will ask the tool to actually analyze those differences and just show me the unique ones. Okay, just don't show me the same change again and again and again. And this takes a few seconds to run. But this is extremely important because all the visual test automation tools allow you to have this accept everything. Okay, and this is good in cases where you just don't want to, you know what you changed and you don't want to look at it 1,000 times. But the risk is that if there's another bug hiding there and you just accepted it, you prevent the tool from ever detecting that issue because it will expect the bug moving on it, right? So let's let it finish here. And we're done. And you can see that basically we only have 2 images to look at. 90 of them have exactly the same change at the footer. And again, it doesn't matter that it's different browsers and different pages and different layout modes. It's still the footer plus changing to a minus. The tool can see that it's exactly the same. So we can just accept this. All of this is fine. We can accept them at once. And then we can look at the other image. And we can see that it's good that we didn't accept it because we had a bug. Okay, so it's a safe way to handle like masses of changes very easily. And in fact, there are many things like that you can do with visual testing. So one thing that no tool will ever do is be able to decide instead of a human being if the change is a bug, if it's good or bad, if it's valid or not. A human has to look at it and decide. The reason I can say it with confidence because after years of working and managing R&D teams, I've seen people argue if something is right or wrong. So I cannot imagine a case where a computer can decide it for humans. But once a human has made this subjective decision, there's so much that can be done to automate this decision, and all the parts that a machine can do can go in that position. So it can be stuff like that. It could be the ability that if I just said that a certain area is dynamic and I don't need to look at it, then you can apply this decision on 1,000 tests. You don't need a human to go and define that area again and again and again. Right? There are many situations that can be done. And basically, if you can think of ridiculously ideas of if I could just change the code of my test, I could have a machine that would fix all my tests for me. When it comes to code, that would never happen. When it comes to images, there's a lot that can be done, and that is which just to clarify that we have teams that are using specifically our product that are running tens of thousands of visual tests every day, just for one team. And they can handle this load and with very little maintenance because of features. And that leads us to the last topic, unless there are questions at this point, which describes how all this fits in the development lifecycle. And the quick answer is that it fits in all stages. So if we look at unit tests, then we already talked about front-end developers using this type of tools to test their components. The components are small, the tests run very fast, it works very nicely with code reviews to see the differences immediately and review them. When it comes to integration testing, then you saw how easy it is to take an existing Selenium test, which is often used in integration testing, and turn it into a visual test. You can focus on entire pages or just parts of pages. It depends on the quality of the tool and how many teams are responsible for that page. Is there one person that is allowed to decide what's right and wrong for the entire page, or just specific teams and product owners that are responsible for different parts? And all these effects on the way that you test it. An important thing about this type of testing, as opposed to functional testing as you know it today, is that it allows you, for the first time, to catch unexpected changes. Okay, in what sense? If you think about your automated test today, regardless of what tools you have, there are two types of things you do in those tests. The first one is simulation code. You click buttons, you enter text, you hover on stuff, you move the mouse, right? This is simulates what they usually do. The other part is assertions, right? You write assertions that assert certain things that you expect to happen that really happen. The problem is that test automation in that sense only guarantees that the specific routes within the application, the specific functionality that you decided to validate continue to function. But everything around those assertions can break, but the test will still pass. Right? This is a limitation of test automation. When you do testing this way, especially if you capture entire screens, then you start catching every change. Nothing slips by you. And this has two implications. For quality assurance, this means that you start catching unexpected changes. But beyond that, this also becomes a very important collaboration tool, because it allows everyone to see not only the bugs, but also the changes that team members are making. So let's say that I'm a developer right now and I just committed my code for a new feature or a change that I did. As soon as the test will run, if you're doing continuous integration, that could be like in the next hour, everyone, the tool will capture the change. It's not a bug, but everyone can see it. And within the hour, I can get feedback on what I did, whether they like it, if it's nice or not, if it's bad, if it ruins something else, etc. Or if it was a great thing that I just added, and everyone will tap on my back and tell me it's a great feature and very nice. You don't have to wait to the end of the sprint for the demo in 2 weeks' time for everyone to see it. Okay, so it's become a very strong and powerful collaboration tool if you embed it. When it comes to acceptance testing, it's very, very common to use the baseline of the previous version and test the release candidate against it, and just look at all the changes and make sure that all the changes aren't any unexpected ones. The other way to do it in a dynamic environment, if the application is extremely dynamic, is to use the same test at the same time against the production and staging environments, dynamically using the production environment as a baseline to compare against the staging environments. It's the same data at the same time. It should look exactly the same for the most part. And it's a very effective way to do it at that point. And of course, there are many teams that use visual testing also in production to monitor their live production environments. It is useful if you don't have time to test before releasing. It's useful to make sure there are no missing resources in your production environment. If you depend on third-party data or components, and immediately if they change or break or whatever, you immediately see that. And of course, if the OS upgrades, the browser upgrades, you immediately catch that and you can handle it if it breaks anything. So with that, I conclude my talk. Questions?
Obviously, you mentioned the one company.
Yeah.
The organization size. Any recommendations for how you do source management of the images, particularly if you have a bigger team? Any good recommendations?
Yeah, so as you can imagine, every team can have their own process and their own decision makers and stakeholders, authorities in the team. There is a huge variation in the way the teams use it. So I've seen situations where uh, everyone that knows the product can make the decision if it's right or wrong. I've seen situations, especially with the highly regulated industries like healthcare, where there are specific people that are allowed to approve baselines, and so the tool is built in a way that everyone can run tests, but only there's a specific person in a team that is allowed to approve the changes because it's being audited and they can't allow any mistakes for someone who is not authorized to just approve a change. When it comes to full page screenshots versus components, then there are two main factors here. The first one is the quality of the tool itself. So the bigger the picture is, the more likely to have all these issues that I've shown before, the scaling, the things that are moving, and then you start using thresholds that are more permissive in order to handle all of these, and it makes room for bugs. So the recommendation there is to zoom in and take small pictures because then you can use a lower threshold. So if the tool doesn't have a strong enough image comparison engine, that would force you to have like many validation of many small components. The disadvantages are clear. It's more maintenance, you have to write in the code and identify each element. Um, you have to really worry about as your application changes, you need to fix those element identifiers so they would continue to locate the same element. So there's a lot of overhead there. If you have a stronger tool, you can do full page screenshots, which is much less maintenance. And on the other hand, if the team is very big and there are many teams that are working on the same page, it's sometimes difficult to coordinate that and find a certain single person or authority that is allowed to approve the whole thing. And that's another motivation to split it into components where each team manages its own set of screenshots, right? And so you cannot reach a point where everything has to look right, and that's a single point of validation. So these are the main factors that I see. And of course, there are teams that where front-end developers are doing the validation. There are teams where it's part of the continuous integration and every build gets validated. There are teams where it just acceptance test. So they just use the tool before releasing a new version. That one time they run it, they look at the differences. There are many differences, but it's okay because it's part of the acceptance testing process, and that's what they do. And there are teams that only worry about production. Okay, there are many websites that don't change often. It could be thousands of pages, let's say, even localized. Pages in Japanese. No one in your team can even detect a bug if you would see it with his bare eyes, right? So they just run a simple test that has like 1,000 URLs and it continuously loops through them and validates them. Whenever anything breaks, changes, a hacker hacks your sites and puts some other text there, it gets detected. They look at the results, they understand what happened, how to fix it. If it's a different language, it sends the URL to the translation company and they just look at that and tell them what's wrong, what to fix. And so there are so many ways to use those tools. I hope it kind of gave you a picture. There's no one way. Yeah.
Say I'm using a cloud that's from inside Selenium and Ruby.
Yeah.
What's the mechanism for saying?
Question was, how do I let the tool know that I want to ignore certain areas that are dynamic or whatever, or not important. So it depends on the tool. So some of the tools will allow you to specify areas to ignore, just DOM elements. Okay? WebDriver CSS, by the way, does a very good job. You can actually describe like arbitrary shapes to ignore, not even rectangles. And usually if the tool is based on a WebDriver, that would be a by selector of WebDriver to get the element, and then the tool and when it runs, it looks at the dimensions and ignores it. So the majority of tools work that way from the SDK. With Applitools eyes, you can also do it directly on the UI. I can show it in a second. So yeah, it's now back on. Well, I won't show it. Windows updates, that's nice. That's never happened to me in a presentation. Yep. Nice. Okay, so you can just draw the regions that you want to ignore on your own, and with automated maintenance